I want to talk today about risk in regulatory approvals. So have a quick hands up. Who here is a manufacturer of products? All right, good. Who manufactures a product and has some radio function in it, like RFID, GPS? All right. Who manufactures a product but doesn't have any radio in it? One person. Oh, two. All right, cool. Now, actually, I tend to talk in radio terms, but everything I'm going to say applies equally, whether it's radio enabled or not. The same concept applies. So this is me. I'm not here to talk about who I am. I'm talking about risks in regulatory approvals. So for those manufacturers, do you understand the concept of regulatory approvals? Like you make your product, you test it, and then you can sell it, right? And I thought, well, I want to talk about risk because there are a lot of risks in this process. And I've been talking at events like this for a really long time. And I mean, it's a pretty boring topic. Regulatory approvals is a pretty boring topic. And I thought, how can I make it a bit more fun? And so I thought, what can I do to introduce the concept of risk into my presentation? How can I introduce risk as an idea? And I thought, probably if I get drunk, that will be the best way. So I thought, that's what I'll do. I'll come out here, I'll get drunk. I didn't expect that all the audience would be drinking as well. But I thought that way, as the presentation goes on, we can see a real-time demonstration of how miscalculation of risks can affect the outcome. Because in reality, this presentation is my product today for this next 25 minutes. And so me placing my product on the market is me delivering this product to you. If I place this product, if I get through this whole presentation and you learn something, then I have successfully placed my product on the market. And of course, I want to capture your imagination and I want my presentation to be slightly different to the presentations you've seen before, hence the alternative approach. But then you stop and you think to yourself, okay, how does risk work? And is this going to go really well? And I thought, actually, some people don't drink. Some people are really anti-drinking, and I could alienate a big section of the audience straight away. And then I thought, secondly, I'll give this presentation, and then, full of endorphins, I'm a bit nervous, I haven't eaten my dinner. I'll be back at the Element booth afterwards going, wow, that went really, really wrong. That did not go well at all. Halfway through the second pint, I forgot what I was supposed to be talking about. When I fell off the stage, it's lucky that I'd moved on to tequila shots because I spilt it all into the mains block. And if it had been a pint, it wouldn't have just knocked out the building. It would have been the whole street. And so I came to the decision, this is a non-alcoholic beer and I'm not going to drink it all. But it's very tasty and it's refreshing. But it's a non-alcoholic beer. So I've got my joke across, but I've significantly reduced the risk of falling off the stage or forgetting my lines by planning and putting a non-alcoholic pint down there in the first place. And so that's the kind of concept I want to talk about. Not risk assessment like do something crazy and then go, all right, wow, okay, how are we going to fix this now that it's all gone wrong? I mean, how can we plan ahead and think what will go wrong and how can we reduce that? And so that's why risk assessments or risk planning in regulatory compliance is all about thinking before you get to the testing stage. In fact, it's thinking about the risks in the product development stage. So very, very briefly, I'm going to talk a bit about risks in approvals. We haven't got long, so it's a very brief overview. I'm going to kind of pick on the USA, FCC, and the EU, like Radio Equipment Directive, as examples. Going to talk about some of the risks that manufacturers face, and therefore the decisions that a manufacturer has to make. And you might think, well, I don't really make decisions. I make products and I throw my product at the test lab and then they give me a test report. But it's not that simple, or at least it shouldn't be. I'll talk a bit about radio modules. This is really an area of expertise for me, which is an embarrassingly geeky thing to say. But I've written a lot of papers on modules and I advise the FCC and the European Commission on that topic. So I spend a lot of my life on this very mundane topic here. So I will mention the EU directive risk assessments that all manufacturers have to create. And we'll talk a bit about some common mistakes and hopefully have some time for questions. So if we talk about risk management, you'd say regulatory approvals, surely there are no risks. If anybody here like me has ever read the FCC rules, the word risk doesn't really jump out at you. It's written by lawyers and checked by engineers. It's pretty clear what you're meant to do. And the European directives are also pretty clear, followed by Commission decisions. And then you end up with these standards. And the standards tell the test lab or the manufacturer what testing needs to be done. So if the rules are clear and the test standards are clear, there should be no risk. If I pass the test in the standard, I can sell my product. If I don't pass the test in the standards, I shouldn't sell my product. It's very, very simple, you would think. And I put this slide in just to make sure everyone's absolutely clear. In the USA, whether it's radio or non-radio, you're going to follow either certification or SDOC routes, or in most cases both. So this laptop would be both, for example. And in the EU, we have directives, and the manufacturer does an assessment and signs a declaration to say, I believe my product meets this directive. With this one, testing is absolutely 100% mandatory. It's not a declaration that the manufacturer signs, it's a process or a procedure. And if you haven't fully tested every hardware variant or version you sell, it's legally not compliant, regardless of what you put on the label. Whereas with the EU, you have a bit of flexibility. You could say, well, I've got 5 models, they're all a bit similar. I'm going to fully test one and do partial testing on the others. And legally, you have that option to say, I'm going to sign my declaration based on my assessment. So they're really quite different regions. But regardless of whether we're talking North America or Europe, the standards seem very clear, but they also contain choices. So the people who wrote the standards, for example, will have said, just test a selection of channels. Like Bluetooth has 79 channels. You don't have to test all 79. You typically test maybe 2 or 3 of them, depending on which region you're going to. It doesn't mean the other 77 are allowed to fail, or 76 are allowed to fail. It means that you could just test 2 or 3 of them. And it suggests some extremes of temperature that you would test your product over. And that's a way for the manufacturer to have an idea, is my product going to be okay? So the standards contain decisions within them, even though they seem very clear. And then the manufacturer does have some choices to make, because they might say, well, I know that Wi-Fi, for example, often the lowest and highest channels, the manufacturer reduces the power on the lowest and highest channels to make them fit neatly within the band. So if you ever buy in a CE or FCC radio module for Wi-Fi, you have to retest, but you have some choices of how much retesting you want to do. But how much do you know about how much power reduction? You might be testing the most likely to pass channels if you just tested the bottom and top. So you're responsible for looking and going, I really need to understand my product, and maybe just following the standard isn't the right one. And similarly for temperature, if you make a radio product and the standard says, right, test it from 5 degrees to 35 degrees because it thinks maybe you're going to be in a normal home. But you want to put it in a vehicle, which could be in winter in Finland and in summer in Greece. And so you might say, well, the standard says this, but that's not what I'm selling. I need to think about, I'm signing a declaration to say my product will pass in all of the environments it will be used in. So just following the standard may not be the right thing. Worst case cables, like if you talk to some people about risk, they'll draw a little graph and they'll say, right, you've got one axis is the likelihood of something happening, and the other axis is the severity of consequences if it does happen. But then you could say, well, what about cables? You either pass with a good cable or fail with a bad cable or whatever. But in reality, you could also find yourself asking, what are the likelihood of somebody using a poor quality cable? So you might say that the standards won't say you must use this cable. They'll say, test your product. And as a manufacturer, you're responsible for checking, okay, is it worse with the cable connected or is it better with the cable connected? And which type of cable gives the worst results? And same with worst case modes. Like this laptop probably does hundreds of things. Like right now, it's connected to Wi-Fi. It's displaying a PowerPoint. It's got lots of cables connected to it, but not every port. I can hear the fan going. It's probably accessing the hard drive. It might even be backing up the hard drive. Goodness knows what it's doing. And I've got no idea if this exact combination of events was ever tested or whether the manufacturer just tested some other ones. But if you make a product that does lots of different things, which most of them now do, you'll go to the lab and they'll say, set it up in its worst case condition, running in its worst case mode, because that's what the standard says. And you either know that through hard work during the development process, or you'll stand there looking blankly at the lab saying, well, what is my worst case mode? And they'll say, this is your product, you know. And now worst case sample to test. I'll talk a little bit more about this later, but I work for a test lab. And so it sounds silly for me to say this, but your test report legally is a useful document, but it's not that useful. It's a bit like an exam certificate from university or something. It's your way of saying that on a particular test on a particular day, I did okay. But then when you start work, everything is down to how are you performing in that job. They're not going to go, Michael was rubbish at his job, but his school exam results were pretty good, so we'll keep him on. They're going to look at how you're performing on a daily basis. So if you perform well in the test lab, and then your product is bad in the real world, it kind of highlights that your test report was useful, but it's kind of forgotten about when you start selling your products. And how your product is used, of course. You know, I've got this radio transmitter. A lot of my time is spent on RF exposure to body tissue. And it's clipped onto my belt here. I've had children, so I'm not too frightened, but you know, it's always a worry, right? And we're working with companies that have glasses, really high frequency transmitters next to your eyeballs. And a lot of these things haven't been researched yet. And so these are very real risks to consider. One of the biggest options for a manufacturer when it comes to the risk assessment is if they take a module, let's say it's FCC certified or it's got a CE mark on it, and they shove it into some other product. You may not have to, if it's a FCC certified module, you may not have to certify the end product because the transmitter has been certified. If it's Europe, the CE mark doesn't transfer over, so you're effectively scrubbing that off. But in both cases, you have to retest. You have to test the end product to make sure the end product passes. But if you've got access to the test reports from the radio module and you can do an evaluation, you might not have to test everything. So then you've got the case of a big standard, and you're saying, based on my risk assessment, I'm only going to do these small subset of tests. But it's not a guess. I've really thought about this. There is not one definitive list of tests you have to do, and there is not one definitive list of tests that you don't have to do. It's up to the manufacturer. Guidance does exist, but it's things like, the guidance says things like, retest anything that could have been affected by your installation of the module into your product. So you are expected to know everything about what you're doing. Often people will say to the lab, what tests do you think we should do? And we can advise you. We can definitely say, yeah, do these ones. Don't worry about these ones. Here are some gray area ones. Go for it. But if it all goes wrong in the real world, and when I say all goes wrong, I mean your product has problems, you know, it's the manufacturer's decision on all this. Some manufacturers, if they install a module or they do different things, they'll just turn up and go, right, we need to hire a consultant, we need to employ compliance experts, and if we look at the radio module's test reports, we can go through it in detail, we can find the channel and the modulation type that gave the worst case emissions, we can look at where it is in relation to cables, and by doing that, we can spend the absolute minimum time necessary at the test lab. Other manufacturers might say, we don't have time for that. We don't have a compliance expert or an EMC expert. Let's just take it to the lab and test it. I have seen people spend weeks trying to justify why they didn't do a half-day test, which is fine if that's your requirement. But usually the manufacturer's strictest thing is getting to market as quickly as possible. You'll recover your costs very quickly once you've got your product to market. and a good product too. So most people, as a compliance manager, you probably think that your boss is constantly saying, whatever you do, please don't overspend at the lab. Don't overspend on compliance. Don't spend more than you need to spend on compliance. But what they really mean is, don't spend more than you need to and don't overspend. But whatever you do, do not let our launch date slip and do not let us sell a non-compliant product. So they mean that within those sort of boundaries or caveats. There are some calculated risks that a manufacturer takes then. When the risk assessment, if you like, is the manufacturer saying, here's my product, what standards do I need to test to? Which rules do I need to test to? And then within those standards, there's lots of different tests. Tests, for example, that say, do this test if your product has a cable of more than 3 meters. Don't do it if it hasn't. You have to decide what are the likelihood of somebody putting a cable of more than 3 meters onto my product, things like that. So a manufacturer could find a worst case mode or worst case configuration by doing some investigation. I remember Roden Schwartz last year said that it was the first time in their history that they're selling more test equipment to manufacturers than to test labs. So more manufacturers are doing this research as they go along, but also, of course, the test labs will help with that. But finding out what is a worst case mode, you could just turn up to a lab on the compliance test day and say, test my product, and they go, what's your worst case mode? And you go, I don't know, that one, press go. And okay, that's fine, but how much confidence will you have to turn to your boss and say, yeah, it's okay to sign this declaration now? The more you know about how your product works, the more you can reduce testing at the time. You can say, I know that if I just put 2 cables on here, it will pass. And actually, we make lots of products that are all very similar to each other. And each time we do this test, we learn a little bit more. We must remember it, keep that data, and pass it on to colleagues if you want to retire. But then there are unknown risks that manufacturers take. For example, a bunch of people sitting around in suits in a conference room saying, we've got 5 models, they're all quite similar to each other. We can't afford to test them all. Which one shall we test? Shall we go and ask the engineer in the lab which one gives the worst case results? Well, that one has got the most buttons on it. Let's test that one. So there's no technical justification, and really there's no legal basis to stand on. But it happens all the time. Manufacturers just guessing, well, I think it would probably be worse with the cables on. All right, why? And if you can answer why without getting a red face, then that's good. But if you can't, it's really an unknown risk you're taking. So if you don't know how your product works, that is effectively a risk. And so for EU directive compliance, the manufacturer must create a risk assessment. Only the manufacturer can do it. And it's not like you make a product, then you test the product, and then you go, oh crap, that guy at Hardware Pioneer said I got to write a risk assessment, and so you quickly write something. It's not that at all. It's the first document you open. It's more like a blog. Dear Diary, I want to make this product, I'm going to put Wi-Fi in it, and I know that these standards will apply. But I don't know if these ones also apply, so I'm going to test these ones and this mode. And so you're documenting everything you do, and then when you get to the end and you've got all your results, and then you ask yourself, have I done everything I need to do? Hopefully the answer is yes, but if it isn't, that triggers you to go back in the lab and make a couple more measurements. So what other risks are there? I used to work in a lab years and years ago, and all the time manufacturers would go, here's the product we're going to test. This is our golden sample. Nobody touch it, nobody touch it. Don't wobble the table, it's going to pass. And then you get this beautiful test result of your golden sample, and then all the products you sell are probably failing. And if you ever get, it's not about market surveillance. Market surveillance is not your biggest worry. But the customers out there who write the reviews and decide if they want to keep buying your products, they're using the ones you actually sell. So rather than test a golden sample, I would always recommend test a rust sample, rust-colored sample. That's right, the worst one. And then you know that whatever you sell is better. We work with some manufacturers, and obviously they've got deeper pockets than some, but they will pre-test 20 or 30 production products and then find the worst one and send it to us. And they'll go, this one's worst for emissions, this one's worst for Bluetooth radio, and this one's worst for radiated immunity, and this one's worst at other EMC. Test them like this. And if they all pass, we're on easy street and we can relax. Too many modes. So I said about the laptop and all its modes. I've had manufacturers say to me, my product's got too many modes to test them all. And I get that, I really do, I sympathize. But if you read the FCC rules or the European directives, there's nothing that says test the modes, oh, you know what, unless it's over about 10 modes, in which case just forget about it. There's nothing that says that. It says test the worst case mode. So at some point you'll be playing around with modes and you'll reach a realization of, well, it's not getting any worse now, so we've probably found the worst case one. And of course, if you're passing the tests by a tiny amount and you go, wow, we passed by 0.1 of a dB, yippee, let's sign the declaration and sell it. How much confidence do you have of your factory manufacturing quality? Are they using the exact same components and are they selling them all exactly like that or better? All right. If anybody's got little children and you ever played hide and seek, well, I'm talking really, really little children, they'll do that thing where if they close their eyes, they can't see you and therefore you can't see them. You know, like if it's not there, if I can't see it, it's not there, right? And people are like that with test results. They'll say, oh, I've got to do this emissions test on my product to make sure it's not going to interfere with other things and cause, oh no, there's a clause that says we don't have to do it. Brilliant. And so they'll go, okay, I think if we apply this clause, we don't have to do it. Or I put a radio module in my product and the guidance says, only test the things that will have changed. So I think if I decide that nothing's changed, then I don't have to test anything. So that's really cool. So that's cheap and it's quick. So, but how do you know? It doesn't really matter what the standard says. It matters what you're selling. And you can get some really significant test reductions through just testing a single channel, on one mode, but you've got to know what you're doing. Also, the test standards for radio transmitters, they're all written for one transmitter. Like there's a standard for Bluetooth, a standard for Wi-Fi, a standard for LTE cellular. And those groups don't meet each other. They don't come together and say, okay, what will happen if this guy puts Bluetooth, Wi-Fi and 4G into a product? They'll assume that the manufacturer knows exactly what to do in that case. You'll test all the different radios and then as a manufacturer, you'll say, but in addition to those standards, I've got lots of radios. I'll put them all together. What might happen? Any of you are geeky engineers like me, you know all about intermodulation products where signals can mix and you have emissions or problems that create. If you've got a GSM device and a Wi-Fi device and a GPS device, then the harmonics of the cellular could be in the GPS frequency band and the third harmonic could be in the Wi-Fi frequency band. So that's affecting your performance of your product. Some common mistakes: lack of planning, lack of pre-testing, asking the lab to decide what they think is the worst case mode of your product, thinking it's simple. Years ago, this was really simple. People would come to me and go, I've got this radio. You press this button, it transmits at this signal, AM. Please can you test it to this standard with this power, and I will need the certificate on Friday. Nowadays, people come along and they go, I've got this product, it's really cool. It's got a screen, connects to the internet, it's audio, kids are going to love it. It's got Wi-Fi, Bluetooth, cellular, GPS, RFID. I don't know what it does. I don't know what standards apply. I need the certificate on Friday. So the Internet of Things means that people are making these things and they're getting ever more complicated. And of course, not knowing your product. So plan early, prepare, understand your product as it's going along. Don't leave it till the last minute. And you mentioned, I said, I've not really mentioned market surveillance. This isn't about getting told off by teacher if you get it all wrong. Although if you get your product stopped at customs, your boss will really, really have something to say about that. But it's more about all of the tests in regulatory approvals weren't just dreamt up. They came about because of problems. So every time problems exist, real life problems, tests get created to solve them. So if you're not meeting them, you're probably going to find those problems in the real world, either through reviews or your product's not working correctly. But you're here, you've come along to this event to listen to people and meet people. So you're automatically better than all the people that aren't here. So that's pretty good. But I would just encourage you to, if you put all this effort into making a good product, make sure it really is a good product at the end stage. So I haven't left loads of time for my pint, but I will happily take any questions if there are any. I will have to put headphones on to join the silent disco. All right. Well, take the rest of the day off then, I think. I'll happily talk more, but if not, I'll be on the Element booth if you want to come and say hello about any of these things. And yeah, feel free to reach out, get in touch. It'd be nice to connect.